Hello everyone, in this video we are going to talk about hybrid electric vehicles. So here's the content of our video, that is what is the HEV, history, its objectives, types of hybrid powertrains, then components of HEV, then we will have some examples of HEVs that are present in India, then advantages and disadvantages over conventional engine, then few of the challenges that HEV are facing today, then we will have a future scope of HEV. Okay, let's start with what is HEV. So, hybrid vehicles uses two or more types of power sources to power the vehicle. Presently, we are using internal combustion engines and electric batteries with an electric motor drive. So, this is known as hybrid electric vehicle. Here you can see this is a schematic diagram of conventional type vehicle, and here it is completely electric vehicle. When we combine both of them, that means we are getting the benefits of IC engines and batteries. So we get the hybrid electric vehicle. Okay, so let's talk about a little bit history of hybrid electric vehicles. So in early 1889, William H. Patton filed a patent application for gasoline electric hybrid railcars propulsion system, and in the same year of its about mid-time, he applied for hybrid board propulsion system. Then in 1896, Harry Day was developed Armstrong Phaeton that was built by the company Armstrong of Bridgeport. Then it was actually built for Rosa Mechanical Carriage Company. Then in 1900, a four-wheel drive series hybrid version of system known as POS, Mixed, was developed by Ferdinand Post. Then in 1931, a half horsepower electric car was invented by Erich Gachem. Okay. So there are some objectives behind the emergence of HEVs that researchers were targeted, like to maximize fuel economy, to minimize the fuel emissions, and to minimize propulsion system costs, to keep it affordable for the common people, and to maintain acceptable performance with a reasonable cost, and the and most importantly, to reduce the conventional car weight. Mainly there are two types of hybrid powertrain, that is series and parallel. But one more is the combination of both of them. So we can say that there are three types of hybrid powertrain. So the first one is series. In this, the two power sources are connected on a series form to power the transmission. And then the fuel goes to the engine, then engine turns generator, then the generator can either charge the batteries or power an electric motor that drives the transmission. Mainly here, the gasoline engine does not directly power the car, and also there is no need to add a clutch because the motor shaft can be attached to the wheels via fixed gear ratio or the continuous variable transmission. So the next one is parallel hybrid powertrain. In this, both the IC engine and motors are attached to the transmission in parallel, and the wheels can be powered by the motor and IC engine simultaneously. And but there is no need to use generator to run the vehicle, and also there is need of clutches and gears. Okay, the third one is series parallel hybrid powertrain. It takes the benefits of both of them, that is series and parallel, and it is also known as power split hybrids. You can see here in the diagram that power split device is attached here. It decides the optimal power distribution to all the sources, so that we get the highest maximum possible efficiency. And this system divides the engine power, yeah, that you can see there are two arrows from engine, which one goes to the generator to produce electricity, and another one goes to mechanical gear system to drive the wheels. Let's talk about some major components of HEV. The first one is engine. It is similar to that we are using in conventional type vehicles, but the major difference is that the size of engine in HEV is quite smaller than the size of the engine in conventional type vehicles. And we can use any of the type, that is petrol engine or maybe a diesel engine. Then we have battery. It stores the energy generated from engine or during regenerative braking from electric motor. It is also maybe of lead acid type or nickel cadmium type or lithium ion. Then we have a electric motor. It powers the vehicle at low speed and assists the gasoline engine when additional power is needed. Generally, we use BLDC type electric motor in HEVs, that is brushless DC motors. Then we have controller. It is used to charge the battery or supply the power to electric motor. Then we have a generator which converts the mechanical energy of engine into electrical energy, which can be used by electric motor stored in the battery. It is also used to start the gasoline engine instantly. Then we have a fuel tank. It is used to store the fuel that would be used by our engine. Then we have power split device. Then we have also body and chassis. So we can also see HEVs in India as well. There are some few examples like Toyota Prius, Toyota Camry, BMW i8, and Maruti Suzuki Swift, and so on. Let's talk about few advantages of HEV over conventional type engines. So first one is regenerative braking. It is seen that theoretically it regains around 30% of energy used. And we know that the weight of engine in HEV is quite smaller than conventional type engines, so the weight of engine also reduced, and the fuel efficiency also increased, and the emissions are quite decreased due to the less burning of fuel, and also it cut emissions of global warming pollutants by around one third or half of times, and it is approximately 2 times more efficient than the conventional type engines. It also reduces the dependency of fossil fuels, and some of the states also offers incentives for owning an HEV, as it have many advantages over conventional type engines. So few of the disadvantages are also there, like it is more expensive than conventional types, and it is quite slower, and it requires a high maintenance, and the cost of maintenance is also high, and the weight of vehicle is also heavy due to the engine and battery weight, and the accident chance is also high due to the high voltage battery. Many of the challenges, like energy storage devices with high power to energy ratios, and also frequent shutdown and startup of HEV is common challenge for it. Higher efficiency in the conversion of fuel to useful power is also one more challenge. And one more is the advanced configurations for propulsion system components. And mainly the last one is to reduce the size, weight, and cost of the HEV. Okay, so let's talk about the future scope of HEVs. So all the major automobile manufacturers are still working on HEV to enhance their product quality. And heavy vehicle like trucks will also be used hybrid system in the future. The efficiency of hybrid vehicle will further increase in future, and the safety feature will also be added in the new generation hybrid cars. And the price of vehicle will also be reduced with increase in the production rate of HEV, and power of car have to be increased in future. So these are some future scope of HEV that we can see. Okay, so thanks for watching this video. If you still have any query or doubt, you may ask through the comment box. Thank you.